Okay. So what is memory? There are different types of memory. Fine. So like RAM is there, ROM, PROM, EPROM, auxiliary storage device, magnetic tape, hard disk, floppy disk, optical disk, CDR drive, CDRW disk, DWD, Blu-ray disk. ये सारी memory है. These all are types of memory. Okay. And one more memory, it is not mentioned here. That is your punch card memory. Punch card is also a kind of memory, but because it is not electrical memory, that's why I think it is not written. So punch cards are also there. See, in case of hard disk, okay, this is the typical arrangement of your motherboard. Inside that motherboard, RAM is situated. Fine. And then data bus. Data bus is used to communicate the data between input, output, and memories. Mainly data bus is used for communicating from this is secondary memory and this is our primary memory. Okay. Inside that processor also one special kind of memory is there, that is cache memory. Fine. And ROM is also there. ROM is also a special kind of memory, and this is non-volatile memory. Non-volatile. Okay. RAM and ROM both is having same behavior, but RAM is volatile memory. Fine. And this is non-volatile. What do you mean by volatile? Volatile means whenever you are doing some work, okay, whenever you are doing some work and certainly power goes off, then automatically whatever content may be there inside RAM, it will be vanished. Okay. Only the content of ROM is there and the this secondary memory is there. It remains there. Okay. So this is what volatile and non-volatile memory. So there are different, this is a typical arrangement of von Neumann model. Fine. In von Neumann model, input, output, storage, and memory. What is the difference between storage and memory? So storage is whatever you are going to store, it is coming under storage. And whenever this storage will be recalled by a particular system, then it will become memory. So these are the memory devices. RAM. RAM is randomly accessible memory. Randomly accessible memory. And ROM is read only memory. Fine. So both RAM and ROM both are actually randomly accessible memory. Randomly accessible memory. Okay. So that's why because RAM's nature is volatile and its nature is non-volatile. Both are same kind of memory. Only thing is that this is a special kind of programmable and relatively costly memory. Whenever you are going to modify something, it will always remain there. Okay. And this is because this is based on power charging and discharging. So it will not there. It will only up to whenever up to the power is there. Fine. So these are the two different kinds of memory. And to make analogy and to make the means how to remember the name, so we rename the name as randomly accessible or RAM and ROM. Okay. RAM is permanent memory and RAM is temporary memory. Beside that, there are different kinds of ROM. Different kinds of ROM. ROM is it is read-only memory, so programmable ROM. Programmable ROM. Okay. Whenever you are able to change the programming or you are able to change the content of ROM, then it is known as programmable ROM. Fine. So how do you change content of ROM? So in later when you are opening your virtualization platform. So to make available this virtualization program with your Windows 10 system, you need to go for ROM BIOS setting. BIOS, okay? BIOS is basic input output system, okay? And this is also known as ROM BIOS. Why ROM BIOS? Because this ROM BIOS is the only system which tells the computer how to start the system, okay? This actually tells you from which place the bootable location is there inside a system, okay? Bootable location. So this ROM is part of motherboard, fine. So it will call the memory and load into, see, BIOS is there, then secondary memory is there, fine. So secondary memory and then primary memory, that is your RAM. So whatever rough work you want to do, whatever work you want to do, BIOS will call the that particular portion where bootable location is there or bootloader is there, it will load it into primary memory and then the system will start operating. Fine. Then come to EPROM. EPROM is erasable programmable ROM. So the example of erasable programmable ROM is same. ROM BIOS is there. The example is sometimes what happen in that BIOS setup, you are having a privilege to uh, store the password, okay, login password. So whenever you are going to store the password and you want to change the password, then this is coming under erasable programmable ROM. Similarly, because most of you have not accessed the ROM, so better example is router. In router system, whenever you are accessing the router, you can modify, you can change a password, each and everything you can do. So this is also done with the help of ROM, okay, and that is erasable programmable ROM. Now come to storage devices. These are the devices, these are memory devices. Memory devices are used for memory related operation. All the operations are volatile in nature, and this is very important, okay. And storage devices stores your media, stores your operating system, and this operating system later on carried to the primary memory, that is RAM, okay. So BIOS will redirect that how to store the ROM. Actually, BIOS is also a special kind of operating system, but with the help of BIOS, you cannot run the program. So to make program runnable, to use each and everything, you need to uh, store, or you need to copy the uh, memory operating system into a main memory. So this is also known as main memory. Okay, main memory. So it will automatically, because if we are going to operate with secondary storage devices and certainly power downs, then there may be chances of hazards. Okay, so to recover or to protect from that hazard, we use main memory. Fine. Now come to this is also known as auxiliary storage. Then device magnetic tape. So those who know, the magnetic tapes are there. Okay, this is based on reels, magnetic reels, and moving head is there. And these reels are rotating constantly. And in previous time, before 2000, there are tapes also, tapes available. So you might have, some of you might have idea about these kind of tape and cassettes, okay. So inside that cassette, each and everything is stored in sequential manner. That's why there are two different kind of memories are there. This is sequential access memory, sequential access memory, okay. Now come to hard disk. Hard disk is also sequential because it rotates constantly. In previous slide, you can see that how hard disk is there. So this is the hard disk, and this head is moved. Head's movement is searching. Suppose this head is moved with respect to this axis. So its movement is like this. Okay. So its movement is like this, and it will access automatically all the tracks and sectors also. So this is how one can read, and there are multiple platters. These platters, inside these platters, you need to access the data. So whenever the person who is having this kind of hard disk, whenever it is he is searching for particular content, automatically systems voices or humming sound is coming there because of rotation of this hard disk. Okay. Then optical disk. So this is normal CD disk. Okay, because it is based on laser read and write head. That's why it is known as optical disk. CD read write disk and DVD and Blu-ray disc. These all are example of optical disc. If you have any doubt, you can ask. Okay, so this is again one diagram of von Neumann model. CPU is there, arithmetic and logical unit, control unit, output devices, printer and monitors, input devices, mouse and keyboard, and memory and storage. So now you are able to understand what is the difference between memory and storage. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Yes.
Fine.
Yes, sir.
So different characteristics of storage devices. Okay. First is speed, then volatility, access method, portability, cost and capacity. Speed. Speed is slow, fast, and faster. Okay. Then volatility, volatile or non-volatile. Access method, sequential and random. Portability, whether the device is portable, you can take the device and you can use anywhere, yes or no. Then cost, what is the cost of this device? High, low, medium. Okay, then capacity is also high, low and medium. Fine. So likewise you can conclude how to characterize the device. Okay, so suppose if we consider different devices, let me show you. Simple memory system. Okay, memory and storage. So let me show you ROM, RAM, cache, register, then uh, RAM is okay. Then hard disk, floppy disk, optical disk. Okay. So these are the different devices available. If we consider the speed, speed is very high. If we give number, okay, low to high, 0 to 5, then this is 5. Okay, cache memory is 4.5, ROM is 4, RAM is 4, HDD is 3, FDD is 1, optical disk is 2. Okay, so this is the parameter how the speeds are there. Okay, so I had written parameter from low to high. Now volatility. So volatility में register is volatile, cache is volatile, ROM is non-volatile, RAM is volatile, HDD is non-volatile, FDD is non-volatile, and optical disk is, it depends whether it is RDW disk. So this is volatile. No. Both are non-volatile. Okay. Now come to access method. Access method, register is random, cache memory is random, ROM is random, RAM is random, HDD is sequential, FDD is sequential, optical disk is also sequential, and RDW is sequential. Then flash or your pen drive. Okay, pen drive, then SSD. These are again SSD is 4.5 or 4 depending on. Then it is also non-volatile. This is 3.5 and non-volatile. The access method is random. Okay. Now portability. Register is not, it is non-portable. Okay. Cache is non-portable. ROM is non-portable. RAM is non-portable. HDD is, if we consider external, so we can say portable. FDD is portable. FDD is nowadays it is not used, floppy disk drive. Okay, there are two different type of floppy, 3.5 and 5/4. Okay, capacity is high here, 1.4 MB, and this is 800 KB. We need to see what is the exact capacity. Then come to optical disk. So optical disk is, we consider simple. It is portable. It is portable. Flash is portable. SSD is portable. Cost. Registers cost is highest. Now let me write the parameters. Highest in terms of per bit. Okay. Not I am talking about the overall cost. I am talking about per bit cost. It is cost per bit storage. So very high. 5. Cache high. ROM moderately high. RAM, HDD, FDD, optical disk, RDW, flash, SSD. Then capacity. Capacity is very less. It is almost 1. Cache is also not 1, 0.5, 0.5. ROM is 1. RAM is 2. HDD is 5. FDD is 1. Optical disk is 2. RDW is 2. Flash is 2 to 3. Then SSD is it is also 4 to 5. Okay. So now you can compare the thing easily. Yes. Are you able to compare? If you have any doubt, you can ask. Am I audible to you all or not?
Audible, sir.
Yes, sir.
Yes, because today I need prompt. Because power is not there. Okay. So without power, I am going to teach you. So that's why I need your prompt so that I maybe understand that you are able to receive my data. Fine. Now, unit of measurement. How do we measure the memory? So memory is written in terms of bits. Okay. What is bit? Bit is binary digit. It is short form of binary digit. So power is either on or off. If it is on, then it is written as 1. If it is off, then it is written as 0. So this is the smallest unit of measurement and two possible values, 0 or 1. Okay. So suppose if we consider a 8-bit number or 1 byte, 1 byte is equals to 8-bit, 1 nibble equals to 4-bit. Okay. So let me talk about byte. How do we write? So the lowest number in a byte is 0000 and highest number is 1111 and 1111. If we take its equivalent, then this number is 255 and this number is 0. So the range of byte is 0 to 255. I'm not talking about sign bit. I will talk about this after completion of this. Okay. So bit is understandable to you. Byte is also understandable to you. Nibble is also. Nibble, the smallest is 000 and the maximum is 1111. So what is that? This is 0 and this is F. So 0 to F is nibble. Okay. And bytes range is from 0 to 255. Now come to smallest unit of measurement, processor and memory speed. So this is millisecond, a thousandth of a second. Okay, this is millisecond, microsecond, nanosecond. So it depends. There are different speeds are there. So you can use any speed. So initially when we started our computer, it was in degree of millisecond. Then in year 2000, it was microsecond, and nowadays nanosecond is the unit of measurement. Large unit of measurement. Now come to powers of 2 are used because computer memory and storage are based on the basic unit. Okay, so let me show you first thing what is kilobyte. Kilobyte is written as 2 to the power 10. So how this 2 to the power 10 is coming? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are two possibilities, 0 or 1 for a particular number. So why this 2 to the power 10 is coming? So this is our question. Now, if we write this number, this is and one more number 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is 0, no doubt. There is no problem with this expansion 0, 10. Okay. Now come to this. This is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256 and plus 512. If we add all the number together, it will give you 1023. You can check it. So 0 to 1023. Total how many numbers are there? Total 1024 numbers are there. And this number is almost equivalent to 1000. Okay, that's why it is written as kilobyte. Kilobyte is not 1000 byte, but it is 2 to the power 10 bytes. Okay, so the answer is 1024 byte equals to 1 kilobyte. 1024, how it is coming? Because 1023 is from means if we calculate from 0000 to 1111, so 0 plus 1023 total numbers are 1024. So this is likewise. Okay, now come to megabyte. Megabyte is 2 to the power 10 multiplied by 2 to the power 10. It will give you 2 to the power 20. So this is our megabyte and the answer is almost 1 million. So that's why it is written as megabyte or million. Okay, so megabyte is 2 to the power 20. Then come to gigabyte. Gigabyte is 2 to the power 20 multiplied by 2 to the power 10. 1000 million is equals to 1 gigabyte. Yes. So now this is 2 to the power 30. Okay, so 2 to the power 30, I'm not going to calculate the exact number, but 2 to the power 30 byte is 1 gigabyte. Okay, gigabyte is shown here. So this is a billion, okay, or 1000 million. So a billion is this number and 2 to the power 30. A complete set of encyclopedias require about 700 MB of storage, 30 minutes of video, 1/4 of information stored in on a typical DVD. Okay. And yes, one more thing, if you want to store 1 hours of video, then it is coming under 700 MB, 740 or 700 MB. That's why the typical size of one DVD is 740 MB. DVD, not DVD, it is CD. Okay, DVD varies from 4 GB to 8 GB. Even 16 GB DVDs are also there. Then come to terabyte. See, gigabyte, only gigabyte is not in analogy. Otherwise, if we take megabyte, so M for million, okay, but G for not a billion, okay. So it must be billion byte. Then it is very good to understand. Okay. Now come to terabyte. Terabyte is a trillion. That is 2 to the power 30. So terabyte is calculated. Gigabyte multiplied by kilobyte, it will give you terabyte. Okay. $20 million 4-drawer filing cabinets full of text. 200 DVDs of information is there inside one TV. Okay. Now come to introduction is there, then ROM, etc. Already discussed, but let me show you. Memory devices. Memory is one or more set of chips that store data, program, instruction, either temporarily or permanently. So this is the definition. Okay. It is critical processing component in any computer. PC use several different types. Fine. Now come to memory devices. Two most important are random access memory, read-only memory. They work in different ways and perform. They actually work in different ways and perform distinct function. Then come to CPU registers and cache memory. So let me show you what are the components. Okay. Hard disk is there. Important thing. Hard disk. I'm not talking about CD or any other devices. What is inside that computer? Hard disk is there. It may be SSD or whatever, but I'm not talking about hard disk. So hard disk is 7,000 rotation per minute or per second RPM like this. Okay. So this kind of hard disk is there. Then come to RAM. Whatever you want to show, whatever you want to display, and whatever computation is going on between these two devices. Okay. After that RAM, ROM is there. ROM actually directs the memory. ROM copies the operating system inside that RAM. Okay. Then only we will be able to perform different computation. Before that ROM, there is one cache memory. Cache memory is very similar memory. Whenever you are going to a particular shop, like coffee house is the great example, or hotels are there. Inside that hotel, salt is always there and paper is always there. So you can use salt, paper whenever you need. Okay. And nobody eats salt and paper full stomach. Fine. That's why it is put there. So the small amount of memory that we want to use for and for, then we know this type of memory as cache memory. So cache memory is, it uses only those portion which is in calculation, and it will enhances the speed of computation. After that, one more memory is there, register, and both are part of CPU. Inside CPU, cache and register is there, and there are different caches also, L1 and L2. L2 is slower than L1. Okay. So on this hierarchy, L1 is highest speed cache and level 1 cache. So cache memory is used for the portion which we want to calculate for and for, and then register the data associated with this cache. So this is the hierarchy, and after that ALU and control unit is coming. So this is the hierarchy of memory, why different kinds of memories we are using. Okay. So this is CPU register, and CPU register, the size of CPU register is very limited. It may be 16 register of 1 byte each or 2 byte each, or it means maximum size is 16 megabyte, not megabyte, 16 byte or 64 byte or 128 byte. This is the size of register, and cache memory size is typically 2 MB or 4 MB cache, not more than that. So what is RAM? Inside that hierarchy, RAM is coming. RAM is a special kind of memory which is randomly accessible. RAM is packaged as a chip. Basic storage unit is a cell, 1 bit per cell. So suppose this is one cell, this is one cell, so 1 bit per cell. Multiple RAM chips form a memory. So whenever we see the design of RAM, then these type of RAMs are there. Okay. And there are several points for connection for data, and this is the RAM. So this says that multiple RAM chips form a memory, and its full form is randomly accessible memory. It is volatile in nature, used for temporary storage. Actually, it is not used for storage. It is used for calculation, like your rough copy. Rough copy keeps your data always, but here all the rough work, whatever intermediate work is going on, it is kept in that randomly accessible memory. Typical ranges are 256 MB to 4 GB. Nowadays, it is very common to use 8 GB to 12 or 16 GB. Random access means direct access to any part of memory. You can access directly. Whenever you are going to access anything from your hard disk, it will take time because it is sequential in nature. But in this RAM's case, it is not sequential. That's why its speed is very high. Then non-volatile memory, it is ROM. Okay. DRAM and SRAM, dynamic RAM and static RAM. See, there are two different kind of RAM or volatile memory, SRAM and DRAM. So whenever we are talking about this, it gives us simulation that dynamic RAM is having very high speed and static RAM is having low speed, but not like that. Dynamic RAM is composed of capacitors. Okay, capacitors. So charging and discharging takes in dynamic manner. That's why it is known as dynamic RAM. While static RAM is based on transistor. So it's because it is not charging and discharging once a data is there, always remain there. That's why the static RAM is faster and dynamic RAM is slower, because we need to refresh after every few microseconds. Memory is retain value even if power is off. Generic name is it. Yes. This is the term. Okay. One, that memory is volatile. So for that person, that particular context, memory is given a name, randomly accessible memory. Okay. Similarly, for read-only memory, ROM is given the generic name. Misleading because some ROMs can be read and modified. Okay. So whenever we are talking about read-only, it is like book, but you can modify, you can change the password, you can change the attributes also. That's why it is misleading. This term is misleading. There are different types of ROM. Programmable ROM, you can program, you can change the program. Erasable programmable, you can modify and update new program. Like in your firmware, sometimes it is asked that updates are available. So download the update and routers. Okay, this is with router, not for mobile. Electrical erasable ROM. if you want to erase the memory, then electrically erasable ROMs or programmable ROMs are there. Then flash memory used in portable digital devices. So flash memory is nothing but your pen drive. Okay. Then firmware. After that, firmware is coming into existence. Firmware means this is hybrid chip. The program is stored inside that read-only memory. So program is stored in ROM. Boot time code, BIOS, that is basic input output system, graphics card, disk controllers, these all are example of firmware. Okay. Even some operating systems are also there, firmware based operating systems are also there. So these all are firmware. Now come to storage versus memory. For memory, like RAM, keeps the information for a shorter period of time, usually volatile. It is faster and more expensive. Storage, like hard disk, the information is retained longer, non-volatile. It is slower in nature because of heads movement, and it is cheaper. Okay, because of this technology based on because a lot of semiconductors are not involved. Still, nowadays semiconductor memories are very costlier. Then come to different storage. Magnetic, like floppy disk is there, zip is very similar to floppy. Floppy stores 1.4 MB and zip stores 8 times more. Okay, then hard disk. Optical drives include CD drive, CD-ROM, DVD, and solid state storage devices include USB key. USB key is a very common form of solid state storage. Actually, it is a key for opening a particular hardware based on USB. So inside that USB key, some username, password, or login information is there. Whenever we attach the USB key, automatically system starts. Magnetic storage exploits duality of magnetism and electricity. So both the principles it applies. Converts electrical signals into magnetic charges, captures magnetic charges on storage medium, later regenerate electrical currents from stored magnetic charge. Polarity of magnetic charges represent bit value and 0 and 1. It means flux change is there. So different values of flux, it will give 0 and 1. I don't know what is the value. Okay. So based on flux changes. So this is example of magnetic drive. Your hard disk drive is also example of magnetic drive. Okay. This is one more magnetic drive. Okay. So whenever you are using your hard disk, don't move this hard disk towards a magnetic field like refrigerator, monitor. So here there may be problem of interference, and due to this interference, your data may be lost and hard disk may be crash. Magnetic disk is flat circular platter with metallic coating, already seen, that is rotated beneath read-write heads. So this is the disk and read-write heads are there. Okay. Random access device read-write head can be moved to any location on the platter. Typically, it is used with hard disk and floppy disk. Cost performance leader for general purpose online secondary storage. Magnetic drives storage capacity, floppy disk is 1.4 MB and hard disk is 500 GB, 1 terabyte, 2 terabyte, etc. Okay. Floppy disk. So this is example of floppy disk. This is the reading portion. From here, the disk is read and this is magnetic material. Okay. Why its name is floppy? Because the material is a thin film based material, and when you means you are doing like this, so it will flip and flop, flip and flop. So that's why the name is flipping floppy is there. Okay. So it is portable, inexpensive storage medium that consists of a thin, circular, flexible plastic disc with a magnetic coating. enclosed in a square shaped plastic shell. So there are different structures of floppy. Initially, it was started with 8-inch, then shrank to 5.2 or 5/4, then 3.5. Okay. But the problem with floppy disk is that we need to secure our floppy in very means delicate medium, because no interference, it is not able to tolerate any little bit interference. Okay. A floppy disk is a magnetic disk, which means that it use magnetic patterns to store data. So data in floppy disk can be read from and written to. Formatting is the process of preparing a disk for reading and writing. So I am having idea a floppy disk can be sustained for 4 to 5 times, not more than that. And the cost of floppy disk, a good floppy disk from Sony, it was around 25 rupees. Okay. So this was very costlier. A track is a narrow recording, a track. Okay. So this is the track inside a floppy. So this is narrow recording band that forms a full circle on the surface of disk. Then hard disk. So hard disk already shown there. Okay. So there are revolutions 5400, 7200 RPM. Storage capacity is 1 TB, more than 1 TB, 200 GB. Okay. And likewise. And this is another form of auxiliary storage, hard disk. A hard disk consists of one or more rigid metal plates coated with a metal oxide material that allows data to be magnetically recorded on the surface of the platters. So this is a typical hard disk, and this circular path is known as track. Data is recorded in the concentric circle bands, and one particular this particular portion is known as cluster. Okay. So and sectors, actually this is divided into multiple sectors. So each track is divided into pie shaped wedges, and this is known as sector. Fine. Optical mask storage device store bit value as variation in light reflection. Okay. Means whatever, actually whenever we are writing, it is like this. So light's reflection, light is penetrated here, and whether this passed to this particular thing or not. If it is not passed, it is reflected. So on reflection, there is some other meaning, and if it is passed, then there is some other meaning. So this is the storage. Higher area density and longer data life than magnetic storage, standardized and relatively inexpensive. Uses, okay. In 2000, for writing our project, the cost of one optical mass storage of 700 MB and reading speed is 2x. Nowadays 48x. Okay. This time 2 times is the reading speed, and the cost for one one such disk was 50 rupees. Okay, rupees 50. And burning cost, because burners, we need to go for a burner, and burning cost for a particular disk is around 200 rupees to write a software that time. Okay. And burners, actually the persons, those who open the shop like internet cafe, etc. So they are having their own burners, and this burner will take 4 to 5 hours to burn one CD. 4 to 5 hours, depending on whatever your data is there. Okay. So 4 to 5 hours required to burn a 700 MB CD. Then come to CD, 700 MP storage. CD-ROM is read only. CD-write is record to CD. CD-RW can write and erase. Okay, you can re-erase. So there are technology, write once, read many, and write once, read once. ऐसा तो कभी हुआ नहीं. Write many, read many. Okay, so this technology is actually, this is just name, but you can use like this. So warm and and WMRM are available. Video disk, its capacity is very high. Okay, then come to compact disk. Compact disk, also called optical disk, is a flat round, actually the track. In case of floppy and hard disk, this is the track. In case of CD and DVD, this is the track. It is a spiral. Okay, portable storage medium, that is usually 4.75 inch in diameter. A CD-ROM is a compact disc that uses the same laser technology as audio CD for recording music. In addition, it can contain other types of such data such as text, graphics, and video. The capacity of CD-ROM is 650 MB of data. Then DVD, over 4 GB storage, varies with format. So here you can see the density. DVD-ROM, it is read-only. Many recordable formats like DVD-R, DVD-RW, these are more highly compact than a CD. Spatial laser is needed to read this. Okay, because in CD it is very easy to penetrate the beam, but from here we need to use a special kind of laser. Then Blu-ray disc, derived from blue violet laser used to read and write data. It is very similar, but the storage is very high, around 200 GB of storage. Developed by the Blu-ray Disc Association with more than 180 members, includes Dell, Sony, and LG. So this is the technology. Okay, because Blu-ray uses blue laser 405 nanometer instead of red laser, which uses 650 nanometers. This allows the data tracks on the disk to be very compact, and this allows for more than twice as spatial bits as on a DVD. So these are the different formats available with Blu-ray technology: BD-ROM, BD-R, BD-RW, BD-RE. So with this, we finish memory portion. Okay, and unit 1. If you have any doubt, you can ask. Yes. All are here only, or they can left?
Sir, our second class has started, so can we leave?
Yes, sir.
Yes.
Sir, time is over.
No,
Our
sir.
second class has
Time is
started.
over. Just 1 minute extra. Attendance is downloaded. If you today, please don't switch on the camera because my bandwidth is not that much. Okay. So thank you very much. I had downloaded your attendance. I will post your attendance also. Okay.
Thank you,
And
sir.
Thank you.
yes,
Thank you, sir.
those with
Thank you.
special name. Okay, they need to mention their name because I don't know. I think everybody has their own name. Okay. So thank you. You can leave now.
Okay, sir. Thank you.
Thank you, sir.